do the screen capture today. Okay, there is a procedure for constructing a frequency distribution. I usually do not make you create a frequency distribution, but I would suggest that you read over that. And it's on the next page, page 46. 6 steps, but I don't make you do a frequency distribution. I usually give you the frequency distribution and you just find the mean, median, and all that good stuff, or the mean and the standard deviation. So I'm going to skip over that area. I'm going to skip over 45 and 46, but you're welcome to read over it, but I'm not going to test you on it. Okay, relative frequency. Relative frequency is when you take the number of, well, I'll just show you. All right, let's take, for instance, I thought they were going to give us an example. That's not the example. Let's see, cumulative. That's cumulative. I was going to find an example of. Okay, here we go. We can do this one right here. Okay, this is a normal distribution, but go ahead and write this problem down. It's in your book. It's tables 2.6. It's on page 49. And if you blow it up a little bit, I don't think everybody can see it. Just draw this and this. That's all you need. Just the first 2 columns. And then I'll show you how to come up with the relative frequency and the cumulative frequency. Excuse me. Once I show you the first, or once I show you one time what to do, then you should be able to do it. I mean, it's not rocket science. It's just, doing a certain procedure, and after that, doing another procedure. Okay, there's our frequency distribution. Now, bring it down a little bit, Dennis, so I can write. Yeah, hit the subtraction button until I'm 95 until it back down pretty soon. There we go. Alright. So I want to do the relative frequency and the cumulative frequency. So, the first thing I do is calculate n. And n is how many people are in the group. So, just add up all these numbers. 56, 66, 76. How many people are in the group? 78. Now once you add up those that are in the group, then you just put this over that number and multiply by 100. So this one is 1 over 78 times 100. This one's 10 over 78 times 100. 56 over 78 times 100. Right here. Adding all these up. And we'll just change that to 76 for some reason, 78. And then 10 over 78 times 100. And 1 over 78 times 100. And that's going to give you your relative frequency. Relative frequency is just a 25-cent word per percent. Alright, you're finding the percentage of the class. 1 over 78 times 100 will give you a percent. So you take your handy dandy calculator. Huh? No, I'm going to just do it right quick. I've been found sometimes when I ask the class to tell me what things are, they tell me different things, so I just do it myself. 1 divided by 78 times 100, and that's 1.28, so that's 1%. So the first and the last is 1.3%. So you put 1.3 here, percent, and 1.3 here. And then 10, take your handy dandy calculator, hit second, enter, second, enter, and then go over here and put insert, second insert, and put a 0, and then multiply that by 100. Just going to move the decimal, is all it's going to do. 12.82, so that's 12.8. Okay, I messed up. Yeah, and then, yeah, this 1.3. Sorry. And this is 12.8 or 13% right here, and this is 13% right here, and this is going to come out to be probably 56% right, or this is 32 or 34, 64%, somewhere in there. So 56 divided by, okay, 56 divided by 78, yeah, 72%. Yeah, 72%. So this is 72%. Now you know how to find the relative frequency. Basically, you're finding the percentage. Percentage of, what percent is 1% out of the group? What percent is, 1. What percent is 10 out of the group? What percent is 56 out of the group? What percent is 10 out of the group? And what percent is 1, out of the group? Okay? And whatever the directions tell you, the directions will tell you. So relative frequency is a 25-cent word for percentage of the group. Cumulative, you take the first number and you put it over here. And what's 1 plus 10? And what's 11 plus 56? And what's 67 plus 10? And what's 77 plus 1? You see why I needed to just show you an example, because an example will show you how to do it. I'm sorry, what?
Basically, you don't have to set linear frequencies.
Pretty much, yeah. This number should match this number right here. They should match. Okay. And And that's what a relative frequency and a cumulative frequency is. On the test, you're probably talking about one problem. Find the relative frequency and the cumulative frequency, and it'll be a problem just like I just gave you. It ain't gonna be long like this. It ain't gonna have a bunch of them. It's just gonna have like 4 or 5. Okay, that's 2.2. Histogram. I told you what a histogram is. A histogram is basically a bar chart where the bars are touching each other. There's your examples of bar charts. Only thing I'm going to ask, histograms. The only thing I'm going to ask you to do on these is make sure you know how to count on a histogram or a bar chart. Make sure that you know that, this is probably, if you pull it up a little bit, Anna, please. Okay, right here, you know this is 0, this is 10, so this is probably like 2. 2, 4, 6, 8, 10. So these are probably increments of 2. This one would be about 34. This one would be about 36. So just to add up how many is in the group, there's 2. There's 34, so there's 36 right there. And then another 36 is what? Maybe 72. And then 72 plus 6 is what? 78. So I'd say there's 78 in the group. What we just did a while ago. Okay? So, got a guy right here. 79 maybe. I don't know if this is the same thing we did while ago or not. 79. And see, you can ascertain that this is 2 because this one is what? 1. See, you can look at so I want you to be able to look at a histogram or a bar chart and make sure you can read it. Alright? And that's all I'm going to ask you to do there. I'm not going to ask you to make one. I'm not going to ask you to, all I'm going to ask you to do is make sure you can read one. Make sure you can, make sure you can see a normal distribution. Normal distribution will be kind of like this right here. See? That's a normal distribution. A little bit to the left because actually it looks more like this. But, make sure you can see that kind of stuff. Okay, we got to this, I think. I think this is the page we got to, did it, or was it not? Yeah. Make sure you know these pictures. This is a normal distribution. This is uniform, looks like a rectangle, just like this. A uniform distribution is going to look something like this. Oops. Sorry. Don't laugh at my drawings. There we go. Oops. Anyway, it's going to look like a rectangle, where a normal distribution is going to look like a bell curve. And a skewed left is going to be to the right. All the data is going to be on the right side. And a skewed right, all the data is going to be on the left side. Now you got to make that distinction because it's always the opposite. Skewed left, all the data is on the right side. Skewed right, all the data is on the left side. So that's the difference. It's always the opposite. Now those are 4 easy questions for the test. Please don't miss those questions right there because you don't want to announce it. Okay? I don't know why I'm yawning so much. Y'all settle down. Keep it quiet. Don't talk too much. Correlation. Remember I told you we were going to get back to correlation. Well, here's correlation. Correlation is pretty much, can you predict something from a pattern? That's what it is. No, that's normal distribution. I thought it was correlation. I'm sorry. I don't cover this. I don't test you on this, but anyway, normal distribution. The points are reasonably close to the straight line pattern, and there is no systematic pattern that is not a straight line. In other words, this is a normal distribution because you see a left to right tendency, but there's no pattern. This is not a distribution because look at this side over here. What's going on over here? You got a bunch of data over here at 0. That's not a normal distribution. And this, does this look like a pattern? Yeah. Anything that looks like a pattern or anything that's got an extreme is not a normal distribution. But I stick with the bell curves on that. I'll let you look at something and see if it's got a bell curve to it. That's all. I thought there was a whole lot more in 2.3, but I guess I'm wrong. Graphs that deceive. Oh, look here. This is a correlation. We can do this right here. Correlation with these two drawings right here. Now, you can blow it up a little bit, Anna. Let everybody see it. They don't have a book. This is on page 61. Now, the best thing to do when you see a scatter plot, and that's what this is draw a line. Just take a ruler and draw a line. So I'm going to take my handy dandy ruler right here. And I'm going to draw a line that goes pretty much through the middle of those points, like that right there. And then I'm going to draw a line that goes pretty much through the middle of these points, like right in there. Now, what kind of correlation do I have? Well, which way do we read? We always read from left to right, correct? So you take your handy dandy marker and you put a little car right here. Do not laugh at my car. Little car right there. Alright, what's that car doing on the first drawing? And what kind of correlation is that? Positive. What's the car doing on the right? Going down. What's that correlation? It's as simple as that. Simple as that. What about no correlation? Well, I'll show you no correlation. Just take your handy dandy. I can't think right now. There we go. There's no correlation. How do you know? We'll put your car right here. What's your car gonna do? Nothing. So this is positive correlation. This is negative correlation. This is 0 correlation. Those are 3 test questions I could give you on the test. Please don't miss them. If you do, don't tell anybody. Because then you have a sign around your neck that says, I is ignorant. Okay? Because I just showed you how to do it. Don't miss it. No correlation. No correlation there. Dot plot and stem plot. Make sure you know how to do those. How do you do them? Well, you basically take a number line and put it like this or like this. Now, with a dot plot, you use your number line and you just put dots. Y'all seen that retirement commercial where somebody puts, how long do you think you'll live? Or how old is the oldest person you know, and you stick a dot way up at 99. And you ever seen that commercial? Y'all haven't seen that commercial? Y'all bunch of losers. Okay, well, I done forgot. If I knew the name of the company, I'd pull it up on YouTube, but I can't remember. It's something to do with retirement. And they take stickers and they say, we want you to take this yellow sticker, and they got this blue back, they got this blue wall like this, and they got it. Let me just see if I can find it. Let's see. Retirement commercial. Oldest person you know. There it is. I'll be done.
Today's generation is living
Hey,
7 years
no.
longer than the previous one. So how do you get people to start thinking about living longer and what it means for their retirement? Well, we built an 1,100 square foot wall and conducted an experiment. With the help of Professor Daniel Gilbert and the city of Austin, Texas, we asked people to place a sticker next to the age of the oldest person they've known. And they did. And who was the oldest person they knew?
The oldest person I really know is probably my grandfather. He's 93.
94.
104 years old.
The oldest person I know is my grandmother, and she's 92, and she's fabulous.
So how did people feel about this longer life that lay ahead of them?
It's really, really true. People can expect to live to be 100 or beyond.
Retirement.
Okay.
About it.
I didn't get listen all.
Hundreds of
I wanted to
Americans
see the
brought to life
picture.
a simple but important point. We're living longer than ever, and yet the official retirement age hasn't changed.
There's a dot plot. Huh? Yeah, they're way up there. Oh, 100. There ain't nobody. Well, there's a couple of people that know the 110, yeah. But a lot of people know what? 100. So that's pretty good. You remember a long time ago, I don't know if you remember or not, but I remember the average age of a man back in, no, not when I was living, but way a long time ago was like 72 years old. Look there. Darn, nobody knows anybody that's 72? That's weird. So
This is the
anyway,
challenge and opportunity of living longer, and this is where Prudential can help.
so anyway,
help.
that's just some
Opportunity of living
little.
longer.
I can't show y'all too many films and stuff, but that right there is a dot plot. It's where the axis is on the bottom, and you put dots wherever you got values. That's it. So make sure you know what a dot plot is. And they usually, on a stem plot and a dot plot, they usually go by base 10s. So the bottom is going to be 60, 70, 80, 90, 100. Why didn't they put 20, 30, 40?
Because that should be the oldest person you know.
No. What are they advertising? Retirement junk. You know, money and retirement and putting away money. So why are they not putting 20, 30, and 40? You don't think about retirement until about 60. Okay? So, dang old retirement, dang old right in here. 65. Dot plot. Everybody good? So y'all can say y'all looked at TV today. Sorry, there ain't nothing more exciting, but you know, I guess you can find dot plots. Maybe we can find some dot plots, some physical dot plotting. No, goes back to boring right here. So nothing exciting, I'm sorry to say. Maybe we could do a dot plot out in the parking lot, build a wall. What do y'all think? Nah. Too much work, right? Yeah, it's hot outside. Let's don't do that. All right, stem plot. What's the difference between a stem plot and a dot plot? Stem plot's vertical. Look. And you don't put dots, you put the numbers. Alright, this is example 6. So, if you was to blow this up, you see that 5? That means 50. That 6 is 60, 70, 80, 90, 100, 110, 120, 130, 140. So how many values of 50 do I have in the group? 50 and 50 what? 56. So I got two 50 values. How many 60 values? None. How many 70? A lot. 70, 72, 73, 74, 75, 76, 76, 76, 76, 76, 77, 77, and then 70 what? 8. That's how you read it. Alright? 50 and 56. Then 70, 72, 73, 74, 75, 76, 6, 77, 77, 78. 80, 80, 80, 84, 85, 85, 85, 85, 86, 86, 86, 86, and so on. If I ask you one of these on a test, I'll either ask you to read it, or I'll ask you to, if it's a normal distribution, or I'll ask you to make one. I doubt I'll ask you to make one because it takes too much time. This is somewhat of a normal distribution, isn't it? And that's what I want to see if you can do, is see if it's a normal distribution. Let's look up here at the other one. I don't know. It could be a normal distribution, but the only thing that bothers me is what? This side right here and this side right here. So it looks like we've got something like this. So I guess you could call it normal distribution, but this right here bothers me. So I think that'll probably mess up the normal distribution. And that's the kind of stuff I want you to be able to do on a test with a box plot, a bar chart, or a histogram, or a stem plot. Just be able to look at it. I'd say no. It's close to one, but it's not because of this right here. Because your normal distribution starts off low, goes to the middle, and ends low. This starts off low, goes up, then comes down, then goes up, then goes down. So I'd say it's close to, but not a normal distribution. And I will make you, it'll be pretty evident whether it's normal or not. I'm not going to trick you. Bar graphs. Well, there's the bar graphs. There's the difference. See how there's a space between these? That's the difference between a bar graph and a histogram. I'm not gonna spend a lot of time on that because I don't want to insult your intelligence, but make sure you can read it. Let's see, this is halfway between 5 and 0. So what do you think that blue one is right there? 2 or 2.5 or 3. This one looks like it's about 4. This one looks like it's about 7 maybe. So make sure you can read it. And most of the time when you are reading, you're guessing. So it's not, now if you say this looks like 576, then something's wrong. Because you can take your handy dandy and if you draw a line from here to here and you say it's 576, then we got a problem somewhere. Okay, we need to fix it. Because it's about what, 13? Where this one right here is about what, 20? This one right here is about 34 maybe. I'm sorry, about 28. And then this one right here is about 38. I'm sorry, 34. Thank you. So you need to be able to read a bar chart or a histogram. Okay? Pie chart. Make sure you can read a pie chart. Let's read one. Let's see if they got an example of one. We'll do one in the homework. A polygon chart or a line chart is the same thing as a bar chart. You should be able to do that, but we'll look at that also. I'm looking at anything that might be on the test. Alright, let's look at this. This is what you call a pictograph. Alright. Now, by looking at these two pictures, what can you ascertain about passengers in 20, 30 years, or 20, let's say it'd be 20, let's say 84 to 94, it'd be 10, 94 to 2004, it'd be 20, 26 years maybe, I don't know. About 26 years, what can you tell me about the passengers that went through this airline? Okay, so let's do this. Let's take a line. Let's take a red line here. Oops, red. And I'm going to draw a line from the tail of this. No, I'll tell you what we're going to do. We're going to make it even better. Let's take our snipping tool. I lost it. I don't know where it went. We're going to take our handy dandy snipping tool and we're going to, oops, can't do that. Nope. Go away. No. Cancel. Let me do it again. There we go. Alright, there's our handy dandy airplane. Now, I'm going to take this airplane out and I'm going to insert, oops, I'm going to insert, I have to go through a different menu here, insert media, and we're going to take that guy, and he's right here. Alright, there's, I was going to try to make it to where that's about right in there. That's one. And then insert. And there's about two right there. And then we could probably copy. Paste. It's not letting me paste. Go away. Now just bear with me. Paste. And then right in there. And then one more. What am I trying to show you? Exactly. So about 4 of these little planes can fit in this big plane, right? So the pictograph is actually saying there's 4 times more passengers in so-so airlines, United States Airlines, in 2010 than in 1984. Now, I don't know what they did say. 8 times. So what is that saying? What is the pictograph saying? Is it accurate? No, it's not. Pictographs are least accurate. Alright? Pictographs, you have to watch them. When you see a pictograph in the newspaper, or you see a pictograph on the news, be very wary, because sometimes the person that put the pictograph on there, they don't know how to proportion it. They don't know how to proportionalize the pictograph to the actual data. Alright? So pictographs, you got to be careful. You say it's right in here. It says 8 times. Okay. Well. So my question is this: does this pictograph do a good job in showing 8 times? No, it does not. And that's the kind of question that I ask you on the test. Alright, so let's look at some questions. And the reason I want to look at questions is I want to make sure everybody understands what type of questions I'll ask you on a test from Chapter 1 and Chapter 2, because Chapter 1 and Chapter 2 is all reading. So let's look. Well, what I could do... Oh, okay, thank you. I could... No, I'll be all right. First to assignment manager. I'll just load one of the tests and show you what kind of questions you'll see. How about that? Yeah, that's great, Hubert. I like the class. Appreciate the interaction. Always nice to have people talk in class.
So it's just gonna be like
I'm going to show you the Chapter 1 and Chapter 2 portion just so you'll see what kind of questions you'll see on the test. That's last semester's. No, I don't want to do that. I want to pull from this semester's because I already loaded theirs. 6. Let's do that one. We'll go ahead and load all of them. Alright, preview. Alright, we ain't got to that yet. When's the week of finals? Okay, should you get that one correct? Good. Does Hubert replace your lowest grade with your final exam? Okay, we ain't got to that one yet. When does the homework terminate? Before the test starts. If you take several forms of tests in Hubert's class, how is it counted? Takes the highest grade. Somebody read their handouts or listened. In MyLab Plus, upon completion of all assignments, the grade book will give me... You sure? I mean, grade book can mean many things. It can mean temperature gauge, IQ test. It can mean all this sorts of other things. How is the homework, test, and exam weighed? Which branch? Marines, thank you. Please get that right. Did I pull any? When is the last day for this class? Good. Alright, here's a Chapter 1. Got the 1 and 2. When a car is randomly selected, it is found to have an 8-cylinder engine. Is this continuous data or is it discrete? What are you doing? Tell me what you're doing. Are you measuring height, length, width? You're just counting. So what is it? Y'all just missed this question. What? Why? I don't understand. How simple can I make it? Come on, people, think. It's discrete. Because it's a what? Finite number. In other words, if I tell you to go out in the parking lot right now and count the number of cars that's 8-cylinder engines, what are you going to do? Are you going to measure? Are you going to count? You're going to count. So that would be B. And you're not going to have any like this. It's either discrete or continuous, one of the two. Okay, here is a frequency distribution. And all they want you to do is tell us which one it looks like. So we got starting off low, getting high, getting high, getting high, getting high, getting to the highest, low, low, low. So it looks like a what? It looks like a normal distribution. So it's either going to be this one or it's going to be this one. What does this say right here? So which one is the histogram? C. So your answer is C. And then it's going to say, does the data appear to have normal distribution? You say yes. So that's a chapter 1-2 question right there. This one you count 0. Now the best, I'll show you how to do these when we get to these type problems. But the first thing you do is put them in order, and then you count 0 to 19 cent, 20 cent to 39 cent, 40 to 59 cent. You count the numbers that's between those. We'll get to that later. Chapter 3. Will Hubert's final exam be online? We'll get to that at the end of chapter 3. End of chapter 3. Oh, no, that's one. So let's do that one. Blow it up a little bit, Vanna, so everybody can see it. And then I'm going to let y'all do this one. All right, class width is easy. What's class width? 5. And why do they ask you the class width first? Because the class width helps you not do a lot of work. Alright? Once you find that the class width is 5, then the rest of it's pretty simple. Alright, what are the class midpoint? Find the first class midpoint. 56 plus 60.9, so I'm going to do that right here so everybody can see it. I take the first lower class limit plus the upper class limit and divide by 2. So 56 plus 60.9 is equal to some number, and divide that by 2. And that is your first midpoint. Now to get your second midpoint, you add what? You just start adding 5. And you add 5 till you get to the end of your, till you get to this 101 to 10, well, I guess it'd be 102.45 or something like that. You just keep adding 5. $103.45, that sound right? Yep. And you're done. Now, let me ask you this. What are these values to? Are they to the whole number, the 10th, or the 100th? What are they? They're to the 10th. So you've got to take your class boundaries to the 100th, and the 100th usually is 0.95. So your first one, what is right before 56? 55.95. And now what do you add? 5s. So it's 60.95. 65.95, and so on. 70.95, 75.95, 80.95. Try not to miss one. 85.95 if I haven't already. Okay, I didn't know. 90.95. Might be able to hit tab. Yeah. 95.95. 100. Oops. 100.95. And 105.95. That's it. We'll go over that in chapter 3. Why does Hubert not entertain extra credit, extra points, and dropping any grades during the final weeks of the semester? B. Good job. You're not going to put because he's mean. What's my email address and phone number? Why'd you pick C? It's the only answer. Mr. Bright, do people miss these problems? Yep, they sure do. That's chapter 3. Chapter 3. Where's all of Hubert's homework and tests done? Online. Okay, that's chapter 3. My math lab, in My Labs Plus, what does Gradebook do? And that's chapter 3. So notice where all of the work is going to come from. Where's all your math? Where's all your questions going to come from? Chapter 3. All right? All right, so let's look at chapter 3 now. Chapter 3 revolves around two things. Well, actually, three things. Revolves around the data-driven set, the frequency distribution, and z-scores. Okay, so it around those three things. Now with the data-driven set and the frequency distribution, there's two things that you want to find, and that's the mean and the what? Standard deviation. Okay, so that's what chapter 3 is going to go over. So let's get started with this stuff. Let's discuss the difference between a data-driven set and a frequency distribution. Excuse me. And we've already talked about that. Data-driven set is what you're used to, like test scores. Unit 1 test, you made an 80. Unit 2 test, you made a 74. Unit 3 test, you made a 92. Unit 4 test, you made a 107. And to find that average, you find the mean, the median, the mode, and all that good stuff based on those numbers. Now, y'all are used to that, and there's not a problem with it. But when I ask you to find the mean and standard deviation with a frequency distribution, some of you don't have a clue. $30, $32, let's see, possibly up to 4. So that'll be 27, 29, 24, 26, and 21, 24. So 5, 3, 4, 10. There is a frequency distribution, and I will ask you for the mean and standard deviation of it. And I guarantee you, if I went through the next class time with the mean and standard deviation, I'd say probably 3/4 of you would be like, I don't have a clue. Okay? So we're going to work on those two things, and then we're going to work on z-scores. So, first, let's attack this, because everybody knows how to do this. Alright? So let's work on this. And then we'll work on this. So let's work on that probably Thursday, but if we can get to it today, that's great. We need to work on this. So, data-driven set. Let's say 70, 50, 75, 78, 83, and 92. There is your test scores. And if I was to ask you to find the mean, median, mode of all that, then you would find them and everything would be fine. Well, let's go through everything. First of all, what do you do before you do anything? You put them in order. You've got to put them in order before you even start. So let's put them in order. There's a 50, and then 70, and 75, 78, 83, and 92. This is your lowest class limit, or your lowest data point, and this is your highest data point. This is your min, and this is your max. Mean. Well, the mean of anything is the summation of x over n. Okay? So, how many is n? 1, 2, 3, 4, 5, 6. And now just add these 5 up. Let's see. 90 plus 80 is 170. That's 175. 175 plus 75 is 250. That'd be 253. I'm trying to go by my head real quick. Okay. Well, what's the total here? 448. So the mean is equal to what? 70 what? And most of you, I'd say probably 99.9% of you know how to do that. That's not a problem. Median. Median is the middle. If you ever get confused, what do you think of when you think of median?
The middle of the road.
Middle of the road. Duh. So middle. So the middle, 1, 2, 3, 4, 5, 6, is going to be these two numbers averaged. Because you've got n is an even number. When n is even, take the average of the middle two. Average of the middle two. So that's going to be 75 plus 78 divided by 2. Somebody give me that number.
76.5.
The median is 77. The mean is 75. So that means your data is pretty tight because the median and the mean are close. They're way off and your data's all over the place. Mode. Only thing you remember about the mode is it's the what? The one that shows up for what? The most. You can have more than one mode. You can have 3 or 4 modes. You can polymodal, 5. You can have 5 modes. I don't really care. Mode's really not that important. Alright? But it's easy for you to get it on the test, so let's go ahead and say, is there any mode here? None. So you put none, no, does not exist, but what do you not put? Do not put 0 because there's always a smart aleck teacher that's going to mark it wrong because they will say, well, there's not even a 0 in the table. Okay, so do not put 0 because everything is marked it wrong. Alright, mean, median, mode, range. Range is your highest plus your lowest, or your max plus your min divided by what? 2. So that's 92 plus 50. That's going to be 142. That'll be 71. Somebody check. So 71 is your mid-range. Now 71 basically is a midpoint. That's going to come up later with the box plot. Okay, so that's going to come up later. It's important for the box plot. Mid-range, I'm sorry, that's the range. Mid-range is what I'm talking about. The mid-range is the midpoint. And that's that. Okay, let's just switch it. This is the mid-range. Sorry. And this is the range. Range is your highest minus your lowest. Duh. Sorry about that. Everybody's allowed one brain bubble a day. Range is your highest minus what? Your lowest. And that's going to be 92 minus 50 is what? 42? Sorry about that. I usually do this on a spreadsheet. It's a lot more organized. So see what happens when we get off the spreadsheet? I don't do it in organized fashion. Alright, and like I say, most of you know this stuff, except when I start asking these extended deviations. And some of you don't know it because you believe whatever the calculator says and don't even know what the definition of standard deviation is. So let's go over what standard deviation is. So any questions on these things? The mean, the median, the mode, the range, and the mid-range. Everybody should know those. Mode, it is the one that shows up the most. If I had another 50 right here, then the mode would be 50 because it shows up twice. But there is nothing that shows up more than once, so there's none. And you need to say none. Do not say 0. Okay? And you'll see some in the homework. You'll see some that has, it'll just ask for the mode. And you'll see it. Okay? Now, I'm going to erase this, and we're going to talk about there's plumbing. Actually, I did the wrong thing. Now, in order to do the standard deviation, you need to know the formula for the variance and the standard deviation. The formula for the variance is equal to the summation of x minus x bar quantity squared over n minus 1. And then the standard deviation is equal to the square root of the variance.
What is that first thing?
The variance. This is summation, and I'm going to tell you that. I'm going to tell you what that is here in a minute. Huh? What goes? Oh, it looks like a big E. Like that. All right. Now, a while ago, we said our mean is what? I'm going to say 75. So I don't have to worry about the decimals, okay? Alright. So, of course, rounding is done according to what the directions say in your homework or your test. I'm just rounding to 75 so I don't have to worry about the decimals. Alright, so what does this say? X minus x bar. So what am I going to do to each one of these numbers to get this x minus x bar? What am I going to do? I'm going to take the mean away from what? Each one of them. So the first one is going to be 50 minus 75. And then what? 70 minus 75. And then 75 minus 75. And then 78 minus 75. And then 83 minus 75. And then 92 minus 75. And that's going to give me a negative what here? Negative 25. So my first column, I'm going to call it x minus x bar, is going to be negative 25. What is this? Negative 5. I'll do this one for you. 0. What's this one? 3. What's this one? 8. Y'all don't speak at one time. What about this one? How much? 17. Alright, now what do we do to x minus x bar? Once we get that number, what do we do to it? Square it. So this will be x minus x bar, quantity squared. 25 squared is 625, I believe, isn't it? 5 squared is 25. 0 squared is 0. 3 squared is 9. 8 squared is 64. 17, let's see, 15 is 225. 16 is 256. How much? 289. Thank you. Now, once we get x minus x bar, what are we going to do? What's summation mean? Summation means add them all up. So what am I going to do to x minus x bar quantity squared? I'm going to add them all up. So add that column up. 625 plus 25 is 650. 650, let's see, 650, that'd be 659. 659, 713, 723, somewhere in there. I'm thinking in my head. It's around 900, it's around 1,000 something. Huh? 1,012. So my numerator for my variance is equal to 1,012 over, what's n? 1, 2, 3, 4, 5, 6. 6 minus 1 is what? 5. So somebody take 1,012 and divide by 5. What do you get? 202.4. And you take the square root of that. And 14.1. Our standard deviation is 14, basically. Now we're going to do another one here in a minute, and I'm going to do it on a spreadsheet. That way you can see everything. Because I can't do everything on one page in my writing. Okay? Alright, so let me pull up my handy dandy spreadsheet. And I'm just going to make up some stuff. We're going to go with just some numbers. 15, 17, 17, 18, 19, 20, 21, 21, 21, 23. Okay? So there's my numbers. Now, I'm going to go ahead and count and see how many there are for you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I want one more. 25. So X is, or N is equal to what? 11, right? Count them again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Alright, take off. I want you to find everything. Mean, median, mode, range, mid-range, variance, and standard deviation. And yes, I want you to do it by hand. I don't want you depending on no calculator because that don't tell me nothing. I want you to be able to understand what you're doing. No sneezing. Can't sneeze or hiccup or yawn in class. I'm the only one that can do that. Alright, I got 19.727 for the mean. Is that what y'all got? Yes, Hubert. No, Hubert. Thank you, class. Yeah. Alright, now that's also called X bar, right? Yes, Hubert. Thank you, class. Y'all settle down. I'm gonna have to bring y'all something to eat or something to drink. Cause I don't know what I'm gonna have to do. I'm trying my best to make this class interesting, and y'all are doing everything you can to not make it interesting. I can get Dr. Gobati in here a couple of weeks. What? Why not? Alright. So what do you do? X minus what? X minus X bar, Hubert. That's right, class. So 15 minus 11. Now if you do use the Excel spreadsheet, you have to hit F4 when you do that. And if you know anything about Excel, you know why. I'm not going to explain it. And there's your numbers. And then what do you do with X minus X bar? Say again. You square it. And you don't forget to put parentheses. And that's going to equal this number raised to the second power. Copy those down. And you should get those numbers. Now what do you do to X minus X bar quantity squared? Add it up, Hubert. That's right, class. And there's my number there. So for my variance and my mean and standard deviation, I'm ready to go. Now I got to find all my other stuff. Mean, median. What do you do with the median if you have an odd number for n? What do you do for the median? You just count down to the middle, right? See, 1, 2, 3, 4, 5. So 20 is our median. Mode. Does anything show up more than once? What? 21 is the mode. Range. Range is equal to what? The highest minus the lowest. Mid-range. Mid-range is equal to what? The highest plus the lowest divided by what? The variance is equal to this guy, 84 blah blah blah, divided by parentheses this number minus 1. And then the standard deviation is equal to that number raised to the 0.5 power, or the square root of 8.48, 2.9. X bar is you add up all the numbers and divide by 11. Now let's see if the data is tight. Is the data tight? Yes or no? Okay, people, you're starting to irritate me a little bit. Is the data type? What tells you if the data is typed? Compare the two numbers. What two numbers? I only said it 5 minutes ago. Y'all are all going to fail this class. Because y'all don't like me and y'all are starting to make me not like y'all, and I'm not going to talk to you. The mean and the what? Median. Are they close?
Yes.
Yes, so that tells you the data is tight. Oh Lord. Let's just see how quiet we can get in here. Is it me? Have I said something to make y'all mad? Is that what it is? Y'all just not going to talk to me. Did y'all meet before class and say, we're not going to talk to you? Is that what y'all did? Okay. Now, how do you use the standard deviation? Well, the standard deviation is a reflection of how tight your data is when the mean and the median are close together. If you have a very high standard deviation, that means you got a lot of slop, you got a lot of variance. But if you have a small standard deviation, that means your data is tight, it's in a group. So, how do you use the standard deviation? Well, you use the standard deviation like you use an estimate. If I was to tell you that I was a painter and I could paint this room, these 3 walls, and I tell you I could do it for $200 plus or minus $50. What does 200 plus or minus 50 mean? Go either way. 250 on the high end and 150 on the what? Low end. So that's what you do with standard deviation. You add it to the mean and subtract it from the mean. So, let's do that. Our mean is what? What was our mean? I'm going to say our mean was 20. And our standard deviation is 3. Draw that. And in the middle, that's 20. And what are we going to do to the right side? We're going to add what? Add 3 and add 3. On this side, we're going to what? Subtract 3 and subtract 3. And that's how you use the mean in the standard deviation. Now, there's a couple of things I want you to look up. Empirical rule. I don't know how to spell it, but I think it's on page 105 or something like that. Somebody look and tell me around 103, 105. Is it on there? It'll have a graph, and let me see if I can find it because I thought it was on. I may have it mixed up with some other class. Hold on. Might have been on 103 and 103 class. I can't remember. 103. Let me turn to it. Make sure you know the empirical rule. Well, hold on. 103. Yep, there's the empirical rule. You need a picture of it. 104. There's the picture. Blow it up a little bit, man, if you need to. There's the empirical rule. You need to put that to memory. Not only will it be on the test, but it will apply to a lot of the questions that you're going to be dealing with from here on out. So make sure you know the empirical rule. $34. 14, 14, 2.5, 2.5. Now it says 2.14 and 0.013, but I say 2.5, but that's just me. What the empirical rule basically says is 95% of the population is going to fall between two standard deviations. That's what it basically says. That 95% is going to fall between here and here. 95%. Go ahead and point it back there, please. So 95% of this, the data that we pulled up is going to fall between here and here. And that's considered normal. 95% falls within two standard deviations. 3 standard deviations be what? 14 minus 3 is 11. This is called unusual. And out here, it's called outliers. Your 6-foot second graders. So if I get a score of 11.2, then that's considered what? Unusual. Well, what about a score of 9? That would be an outlier. A score of 26.5 would be unusual. A score of 32 would be what? An outlier. What about a score of 26? Would be normal. How about a score of 18? Normal. Score of 15. Normal. You have to remember that 95% of the population falls between two standard deviations. 95%. That only leaves 5%, and that 5% is 2.5% here and 2.5% here. So 95% here, 2.5% here, 2.5% here. Now add those up, what do you get? 100%. 95 plus 2.5 plus 2.5 is 100%. Now most of the time your 2.5 is going to be in this area right here, but it all depends on the book and the author. Most of the time the 2.5 is going to fall right there. But in this book they say this is 2.23, this is 0.145, whatever. Alright? But most of the time your book or your author will make this right here the 2.5%. Now, from here on out, whenever you have a mean and a standard deviation, you need to draw it out so you can understand it. Because when we get to chapter 6 and 7, that's all you're doing. Okay? Question on that? And that's how you do a data set. Okay? So you can do those all day long. And you can, and I'll show you Thursday how to do it on a calculator. But the one that you're going to have problems with is the one that we're going to do next, or the one that we're going to get started on next. And that is a frequency distribution. And if I can find it, let's see. I don't even know if this is the right section. Is this the right section? We're in chapter 3, so I guess it is. So 3.3. There we go. There's the formula right there. So it must be in this section. They don't give you the formula. You have to look it up because they don't have it in the actual notes. Oh man. That's the standard deviation of the population. We've already covered that. Alright. I don't think we even show it. I'm trying to find I don't think it's in the book. The standard deviation, see this is of a data set. That's what we just did. X minus, I'm on page 97. That's x minus x bar over n minus 1. That's not what I'm looking for. It looks like I'm going to have to, yeah. So, we're going to quit? No. Let me go to... out of this. There we go. Was that 3.3 I was on? Okay. All right. Write down that formula, blow it up real big for me, so everybody can, you have to blow it up pretty big and move it over so everybody can see it. This is our standard deviation for a frequency distribution. That's good. Now it looks intimidating, but it's really not. If you do it and process it, I'll show you, then you'll be fine. S means standard deviation. What about the mean, Hubert? Well, the mean is real simple. The mean is the summation of f times x over n. So it's real easy. I'll show you how to do that in just a minute. One of those days you just feel like you could sleep all day. I feel like that today. I wish it rained like it did yesterday. No, then I'd be in bed sleep. I'd be napping. At least 2:30, well, not 2:30. I'll pick up my son a little bit. That reminds me, I got to finish up. Alright, bring it down a little bit now. Now, the formula for the mean is real easy. It's equal to the summation of f times x over n. Okay, now before we get into this, and we'll get into this Thursday. S is equal to the standard deviation. N is the summation of all your x's. Okay, so in this case it would be 2 plus 1 plus 9 plus 3 plus 10 plus 31 plus 39. So dang old 70, 80, 89, 90, 95. Somebody check me. You might want to use your calculator. All right, so that's N. All right, everybody with me? 95 is N. Plug that in. Well, what about X? Well, F is each one of these numbers right here. This is F sub 1. This is F sub 2. Your second F. This is F sub 3. F sub 4. F sub 5. F sub 6. And F of 7. So you got all these different numbers. You're going to have to do another chart just like we did on the last one. So F is equal to each one of these numbers. So just mark out that frequency right there and just put F because that's each one of those numbers. But what's X? Well, X is the midpoint. So your first X is M sub 1 is equal to 20 plus what? 29 divided by 2, which is 49 divided by 2, which is 24.5. Somebody check me out. So there's X, we've got F, and we've got N. Is there anything else that we need, or is anything else that we don't have that we can put into the formula now? No, that's it. We've got everything. We've got our F, we've got our N, and we've got our X. Now, Thursday I'll show you how to find it. Okay? Alright, y'all get out, let me get the roll, and y'all get out of here. So we'll pick up my son. Hold on, I gotta upload the, okay, where is my, did I not start the video in here? Where is it? Really bad day. Hold on, I'm fixing to pull it up. Hold on.